Power is the measure of work that can be done within a period of time. In electricity, power is the measure of the voltage and current consumed by the load within a period of time. The symbol P for power is equal to the voltage multiplied by the current. In electrical circuits, the basic unit of power is the watt. A watt is the power used when 1 volt causes a current of 1 ampere to flow through the load. The symbol W for watts is equal to volts times amperes. Most equipment has a power and a voltage rating. This 100-watt lamp is rated at 120 volts. The wattage rating of an electric lamp indicates the rate at which electrical energy is changed into heat or light. The faster a lamp changes electrical energy into light, the brighter the lamp will be. A 100-watt lamp produces more light than a 25-watt lamp. When using lamps that are rated at the same operating voltage, the wattage rating indicates the light output of the lamp and the amount of current it will draw. This means that a 100-watt lamp will draw more current than the 75-watt and 25-watt lamp and will produce a greater light output. To do this, the 100-watt lamp must have a lower resistance than the 25-watt lamp. The wattage and light output depends on the resistance of the lamp. The lower the resistance, the higher the rated wattage, and the higher the resistance, the lower the rated wattage. The basic elements of the electric circuit are the power source, a switch, the load, and the connecting wires. The power source provides energy in the form of voltage, and this voltage causes current to flow in the circuit. The lamp was the load that provided the resistance in the circuit that opposed the current flow. This load used electrical energy to perform some useful function, in this case to produce light and heat. All of the components we've been talking about can be connected in 3 different ways. They can be connected in series, in parallel, or a combination of the two. In a series circuit, there is one and only one path for current to flow. It flows from one terminal of the power source, through the switch, the circuit, and the load, and back to the other terminal of the power source. As a result, exactly the same current flows through every part of the circuit. Up to this point, we've taken a look at circuits that have a single load. In actual practice, you'll very often have a circuit that has multiple loads. It could be more than one lamp, or a combination of lamps and other devices called resistors. If the loads are connected in the circuit so that the same current flows through every part, it is a series circuit. The loads are known as series loads. In schematic diagrams containing more than one load, a resistance symbol is used in place of the symbol of the actual device. Therefore, in solving electrical problems, a schematic diagram of the problem would use resistance symbols instead of lamp symbols to simplify the problem. When more than one of the same device is in an electrical circuit, some method of identifying each individual device is necessary. A system of identification called subscripts is used. This is a method of identifying the letter symbol of the device with a small number. L1, L2, and L3 identify the schematic symbols of the 3 lamps. R1, R2, and R3 identify the schematic symbols of the 3 resistances. While numbers are used to identify individual electrical devices, a small subscript letter following the letter symbol indicates the total amount. ET represents total voltage. Above the ammeter symbol, IT represents total current. The markings serve only one purpose: to identify the individual quantities. It doesn't indicate a value. To analyze the effect of voltage, current, and resistance in a series circuit, let's compare several circuits. First, connect a 100-watt lamp in series with an ammeter and a 120-volt power source, and then close the switch. The ammeter indicates 0.83 ampere on the milliamp display. With the switch open, connect a second 100-watt lamp and a second ammeter in series with the first load, and then close the switch. Both ammeters should read the same amperes. In this case, each one reads approximately a half an amp. There are 2 conclusions to be drawn. 1. When the 2 lamps were connected in series, the current in the circuit was reduced from 0.8 of an amp to 1/2 of an amp, meaning that the total resistance must have increased. This agrees with Ohm's law. And 2. Ammeter 1 and ammeter 2 indicate the same current flowing through the circuit. In a series circuit, the current flow is the same throughout all points in the circuit. To confirm these conclusions, rewire the circuit to have 3 equal loads of 100-watt lamps and 3 ammeters, and then close the switch. All ammeters indicate that there is 4/10 of an amp flowing in the circuit. There is less current flowing in the circuit with 3 lamps than there was with 2 lamps. Notice the decrease in brightness of the 3 lamps. This is due to the fact that each lamp is using less power. If any component in a series circuit fails, the whole circuit is affected. According to Ohm's law, the total current in a circuit is equal to the source voltage divided by the circuit resistance. As resistance is added in series, the total resistance increases. This causes the total current to decrease. Now, 2 conclusions can be made. 1. In a series circuit, the total resistance is equal to the sum of the individual resistances. In other words, RT equals R1 plus R2 plus R3, etc. 2. In a series circuit, the same current flows through the entire circuit. IT equals I1 equals I2 equals I3, and so on. A potential difference exists at only 2 places in a circuit: at the source, known as the voltage rise, and at the load, known as the voltage drop. The symbol E is used to identify a voltage rise. The symbol V is used to denote a voltage drop. If there are 2 or more loads in a circuit, they can be represented as resistances on a schematic diagram, and the voltage drops across them are identified as V1, V2, and V3.